I don't remember if I changed this since we touched this last time. So let's clone it again, okay? Let's clone it again. Because if we run update, maybe it will ask to merge branches, and it's just extra time. I want to skip that part. It's easier to reclone than go through merge branches process, because this requires careful reading and clicking on several buttons. Okay? So please reclone StackData. I definitely didn't touch this one, so we can reopen how it was before. Maybe I edited this somewhere in between. So let's reclone StackData. So I'm going to projects, these StackData. Why do I have two? Okay. Move to trash. Copy. Get from version control. If I change it, it's only I change it libraries, so kind of versions of libraries that it's using it. I didn't recode it. So projects, this section, open, Command V, and Command C, Command V, clone. First, I will use branch, call it main, because it's simpler. And after this, we will look into hilt branch. Okay. Because database logic is slightly it's created slightly differently. But there are major part is similar, so for this reason, second version will be quicker to explain. So let's run this project to see if it's working. Hopefully it does. Just because this project is saving state in database, it remembers what I pushed into Stack. So when you start program first time, it will show Stack empty and empty input. Okay. So if we start pushing stuff, A, B, C, D, eventually it will start, it will be scrollable here, not just entire piece, but also here. Because I'm using lazy list, and lazy list becomes scrollable if it doesn't fit. So E, F, G, H, H, I. You see, it is scrollable now. So not lazy list, it is lazy column. There's no such thing as lazy list. So it is using lazy column, and it is similar to pet data and similar to dog data example from tutorials that asked you to do. So this is lazy column. I already mentioned that this is storing data in database. So when you debug applications that is storing data in the database, you need to see what it's actually storing. Otherwise, it's hard to guess what is going on if it doesn't do what you want, right? So how to see data in the database? We're lucky now because Android Studio now has a feature to show it directly. Previously, we had to download file and open it, this file using different software. And now we can open the database directly from Android Studio, and it is even synchronized if you click sync button. Okay. It will, what is displayed is synchronized if you click sync button. So how to do it? You need to click here and find something called app inspection, I believe. App inspection. So click here, find app inspection. And after this, it will open this part. You will see database inspector. This is for internal purpose. I didn't create this table. It was created automatically. Items, it is the table that is storing the data. If you click this part, you will see what kind of data fields we have inside. It has only ID and value. ID is integer and value is text. Okay. So when we double click items, we will see content, and you see ID and value. Okay. Please notice ID does not have to start with 1. And the reason is that ID is auto-incremented, and each time when I delete it and insert new one, it will increment largest number used. No, not largest number used, sorry. It will increment just counter. So if I have 1, I will insert, remove, it will still increase the counter. So it is not largest plus 1, it is just counter plus 1. So at the previous lesson, I did demo showing properties of a flow, how it is, this program is using flow. What is the mechanic of using flow with database? We can use various data fields, data objects returned from the database, and API supports several kinds of objects returned. We can directly get data object. In this case, this object will contain ID and value. But this method has to, returning this data object has to be suspended, because in order to create this object, it needs to execute query, right? Against file, because it is storing data in the file. So it is delay. So executing this function can take a while, and this is why it is marked suspend function, so it is called as independent task. So it will not freeze GUI. So if we ask for object as it is, matching the row, it has to be only a suspend function. There are other return types, for example, live data. Live data is similar to the flow in terms of it is updated when database is updated. But I think it was a previous idea before flow. They introduced it flow. It has disadvantages because it can do data processing only in GUI thread. But flow can do it in any thread, so it's more efficient in terms of using resources of the device. Live data is still around, and you can get live data. Live data is easier to use with older GUI. But there is zero advantages of using live data with the GUI that we use, compose GUI. Because when you receive live data from the database, you still need to convert it into state object, state of the GUI. So it's still the same process, so there's no advantage. But it is possible. So it is live data object. It's a container which is updated automatically when database is updated. How it knows to update it? It is just re-executing query when you do anything about the table, any update of the table. So it can update data to exactly the same data because, yeah, it's not that smart. So the same about flow. By default, unless you do extra steps, database layer will insert the same data again because it's not checking. It is just triggered to re-execute data query when any update happens to the table. So potentially it can insert exactly the same data. There is a way to fight it. If you care, you can look up how to do it. But it is at the expense of extra programming. So essentially, you define queries that executed and produce the data. And if it is some kind of live object, return it like a flow or live data. This object will be still linked to the database, and when any update of the table happens, it will data layer will re-execute the query, so new data will be inserted, and your GUI will reflect the data. So this is the logic. Android, historically, this is how it started and still using. Is still using this, and it is SQLite database. So, by relational database that comes with Android, it is SQLite database. Unlike commonly used SQL programs, it is not a server at all. SQLite database is not a server. It is just a library to read and write files. So there is no interface to connect to because it's just a library to read and write files. Just because there is no interface to connect to, it is not running as a separate program. It is just a library linked to your program. So it is good and bad. Bad because you cannot share this data, or maybe it's also good you cannot share this data this way. And what is good, data is quite secure. Because it's a file, and files stored in the folder accessible only by the given app, and this is enforced by Linux security of Android. Apps cannot read data of each other because our app is a user, and user has assigned folder, and permissions to read and write this folder. Another app has no chance to read the database of the other program. Okay? So it is a security feature that is relatively easy to enforce. But what if we need another program to read the database for some reason? For example, to get contact list. For email program, sharing contact list with some other program. Okay. So in this case, we have to use content providers. So it is separate interface. And so content provider will connect to database, and content provider belongs to the program that wants to share data. So it requires extra effort to share data from the database of your app. You have to create content provider. Today we are not doing it because these programs do not share data with other apps. Okay? So in Android, database is SQLite. The default database that comes with Android is SQLite. SQLite is written in C, and it's not object-oriented database. It is SQL, essentially. And you know that SQL by default is not object-oriented unless you use library that creates objects for you. For example, you took C# course, you either learn it or will learn that there is object-oriented access to the database in C#. Right? And what was called? I believe it's called entity framework, right? Entity framework or something like this. So, and it is quite common in programming right now that we use SQL databases. SQL itself is not object-oriented, but we use libraries that converts data from the database into objects. So interface is object-oriented. Microsoft provides object-oriented access to their databases, right? And it's part of C# framework, .NET framework. Idea came earlier from Java, and in Java it's called Java Persistence API, and it's also converting data from SQL database into objects and backwards from objects into database. It is called Java Persistence API, but it was renamed recently to Jakarta Persistence API. It is quite mature and rich in features library or framework to store and read data from the database as objects. Android framework to do that is linked to SQLite database, and it's called ROOM. or like room, R-O-O-O-M. Not sure what it stands for. Most likely R is relational or object-oriented, O-O, object-oriented, and M mapping. Because what it is doing, it is mapping objects to relational database. Okay? So this approach is called relational object mapping, relational database to map it to objects. And this approach, it is quite common in programming. Room, it is third common approach in a row. First, it was already mentioned, Jakarta Persistence API, previously Java, renamed Jakarta. Next, it was Entity Framework in C#, and this is third common in Android. In terms of features, it is far less features than in previous two. So perhaps it is for optimization. It has a lot of features, but far, far less than in previous two. Knowing two other helps, but not very much, because it's different API. Ideas are similar, but not drastically. Just because we have less features, it does less things automatically, so we have to do more ourselves. But it's still a lot more convenient than using SQLite directly, because before Room, when I started teaching Android here, we used SQLite directly, and we had to write a lot of code ourselves. When we use Room, a lot of code is generated for us. So in order to use Room, we need to do some sequence of steps. First step, we need to decide what kind of objects we want to store. So we define classes for objects that we want to store in database. And those classes are called entities. It is quite a common name for all object relational mapping. It's called entity. Okay, so in the data layer, data part, in local, it stands for local database here. I defined it a entity, local item, and this object is mapped to the row of the table. So this is how it works. You define entity, it's just a class, with the label entity on top. Name of the table is not required. If you don't provide name of the table, it will use name of the class to create table name. So It doesn't have to be data class. It can be any class. But what is required is keyword entity on top, and something must be marked as primary key. Because what is primary key for database? It is something unique, right? To identify item. So this way, it is inserting and deleting objects when you ask for them. It needs to know which is a unique feature of it, to find it by ID. It doesn't have to be auto-generated, but you need to dedicate some field as a primary key. You can add additional annotations on top of it. For example, you can specify column name. If variable name is not good enough as a column name, you can specify column name as here, add column and specify name of it. We will have examples for it. Okay, or we can just, okay. You see how it goes. Say name and whatever you want this column to be named. Okay, column info, name, and name of the column. Okay. So we will use it later, but in this case, it is good. Name as value is good enough for me. I don't need to rename it. Okay. And when data field is auto-increment, first insertion will have 1. And this trick will help you to know if it is in the database or not. Because this is an object that you create and you save it to database, and after you read it, you can figure it out if it was saved or not, unless you want to trace code or whatever. Please notice that this is val. It means it's not updatable. So when you save it, it will not update this number. It will update what you read back, because this number is not updatable. Okay, it's val. Okay. So if you have an object in your code and this is not 0, it means it was retrieved from database on auto-increment. Right, so this is value. This is table name. Table name items. Why it is called local? It is just a class name. I can call it whatever I like. And in this particular name, I'm referring to local data storage, because potentially it could be stored anywhere. So in local data storage is local to the device. It's not to the internet. As opposite to remote, so if program is storing data remotely and locally, you'll have two kinds of objects. One is called remote, one is local. It's, again, to understand which one is which. Also, I define it stack item object, which is quite similar, you see? But it doesn't have annotations on top of it. Right? What is for? Technically, we don't need it. No, we don't need it at all. It is these kind of objects, like local item and stack item, are quite accidentally the same, right? Because it just happened to be by accident the same. But of course, this has extra annotation, but data is the same. Why do we have two? The reason is flexibility of changing this afterwards. So this is data access layer to store data locally. If later I want to store it somewhere in some different format, I will have to change this, but I don't have to change the rest of the program that relies on this. Okay? So my program relies on these objects. Everything except data access layer. Okay? So if I want to replace data access layer by something, some other data access layer, I will have to change everything related to that one, but the rest of the program logic relies on this. So definitely I would have to copy the data each time, but it's not too much to copy small objects for modern devices. Okay. So this is a way to separate layers. You have if you need to create an object specific to data storage, just, okay, we create that one, but we try not to propagate it to the rest of the program, because if we want to change it, store it differently or in different place, we don't have to change code elsewhere. Okay. It may become more important if you change data types. For example, you store it as a string, but you convert it into something else in your code. And the rest of the program is using data from that string. Okay? So it's not stupid. It makes, in some situations, it makes a lot of logical sense. In this case, it is just demo. Okay? So first, we need to define entities that match database tables. Of course, you know that tables can be related, right? So relations between tables are supported by Room, but far less supported than in Entity Framework or in Java Framework, Java Persistence API. So there is a support for relation, but it is quite limited. But it's possible. You can definitely do it manually. You can define foreign key and just extract it manually based on the foreign key. Another option is to write SQL that will join these tables, just directly into SQL. But there is also object-oriented support for it. It is not covered today. We have one table. There is no relations. It's one table. Okay? But it is possible to do relations. And there are actually several ways of doing it. Unfortunately, it is less comfortable than with other frameworks. I assume it is just because Google wants to have as least code as possible in the library, so applications are not heavy set. So next, now we define entities for tables. Next, we define what kind of operations we want. And we create, quote, data access objects. Data access objects does not have to be per table. It is just objects that you use to access data. So it makes sense to have, to use separation of concerns and create data access objects per tables. But it doesn't always the case, because you may want data access objects that combines tables somehow with SQL query. So yeah, so it is just data access object, but it doesn't have to be for specific table. It could be a combination. So inside of the data access, what is data access object? You define it as interface, because you don't have to write code, which is good news. Previously, if we don't use Room, we have to write actual code for it. When we use Room, we declare what we want, and if we are careful with declaration, Android Studio will generate code for us. So we don't have to write it. So what can we do? We can create a function that is executing query and gets the data. So what do we have here? First one, select value. It is data field. It is column. Column, call it value. From items, Why to say column? 1 second, let me think. Order by ID, it is not ordering value, it's ordering items in the table, right? And this will give me a list of strings. It's not list of items. This is why I have a here column. So it doesn't have to be a list of rows, right? You can retrieve a list of just specific column or combinations of column. And return type must match what you select. Since this column is string, this is a list of strings. Please notice that this function is not suspend function, unlike the functions below. You see, this suspend, this is suspend. And the reason is that it can return empty flow immediately because it's empty, doesn't require too much work. Okay? So functions that return flow and live data are not suspend function because it does not take much effort to give us empty box or empty flow that doesn't have any data in it. This is why it is not suspend. So it provides a flow, but flow will remain linked to the database. So it will execute query on the top, this one, and result will be inserted into the flow, which is already provided to the rest of the program. So there is no delay to get flow, but data will be delayed, of course. So the flow will be in the program connected to state flow, and state flow is the box, right? It has a flow and box waiting for the data, right? Or box pulling the data, essentially. Box pulling the data. Okay. So one way to create functions accessing database is to create functions that return flow based on the query. Okay. So obviously, if I do not say value, I put star, it means select all, right? And in this case, data field would be a list of items, right? No, local items, list of local items. Because row is local item, right? Not row. Yeah, row is local item. ID and value is local item. So you can order by whatever. And what is this one? Again, query, but max ID. So it is in SQL. Max ID, it will give you one item, right? So the returned value is supposed to be integer because it is maximum ID is integer, so max ID. So when we write queries, we have to be careful matching types. Otherwise, it will freak out and will not do what we want. It will not create code. Right? And this has to be suspended because it needs to execute query in order to get integer. Because integer is not empty box that waits for data. It is actual data. So for this reason, return type function is suspend. Suspend function take while to execute. So in this, compiler is enforcing the rule, so they call it as independent task. So you cannot, in coroutine context. So they call it in coroutine context, so they don't freeze GUI. So another update, delete from items where ID is equal to, and this is how to insert data into query. You see? You provide variable, and it goes into this query string with column name, after column. Okay? So this part, it is just this variable. You see, it's matching it. Okay? So next. And now I get just value of one specific item, right? Get item by ID. And what it is, select value from items where ID is equal to this ID. All right. Next, example how to combine several functions into one transaction. Okay. So what is transactions? Things that's supposed to be done in sequence, and if one of them fails, it rolls back. Transaction. So what do I, if I want to delete last item, and this is what I need to do in the stack to delete last item, right? So it has to be several operations. As it is complicated to write one SQL update that will delete last item. Maybe it's possible, but I didn't find one immediately, so I created transaction. It's also examples that we can create transactions. So what do I have here? First, I found maximal ID, and obviously last one has maximal ID, because IDs are auto-incremented. Next, I find item by ID, which is max ID. I delete by ID, which is max ID, and the function is returning what returns what I just deleted. Okay, so you see the function returns what I just deleted. Why? For this purpose. When I pop, you see it goes here, right? Value goes here. G goes here. Last item goes here. So I need to know what I just deleted. So for this purpose, delete last item is returning the string. It is the string. All right. We also need insert. And this function, when you do insert, you don't have to write a query because it knows how to deal with it. So you provide a row, it knows how to insert a row. Okay. There are other functions that where you don't have to write queries. I just don't have them here. You can also have delete, but when you call delete, it's not delete by ID. You have to provide item actually to be deleted. So if you have a function marked delete, you don't have to write query like this, but in this case you have to provide actual item to be deleted, which is extra step, because you need to get it, and after this you call it. Okay. There is also combination of update and insert. There is also update. So if you call add update and provide item, it will update current row with new data from the item. So there is also update. And update does not require SQL query because it is just take this item and replace data in the row from the data in the item. So update also doesn't require this. And there's also combination update and insert. Upsert. Upsert, okay. Update and insert. How it works? If it is not there, it will insert. If it is there, it will update. It's upsert. And in this case, also, you don't need to do SQL for it. So you don't need to do SQL for insert, delete, but for delete, it's not by ID. It is, you need to provide actual item. Insert, update, and upsert, which is combination of in either insert or update. Okay. And what is this? It's another function with query, and this is insert, but it is string. Because you see, if I need to insert without writing query, I will have to provide item. But if I need to push just a string, I need to write query. Okay, questions? So first, you create entities that define tables. Next, you create DAO interfaces, as many as you need. You can put everything in one, it will work, but just use common sense to separate, to organize your code, essentially. So you can have more than one DAO, definitely. Either per table or just any kind of logic. Okay. So next, you have entities, you have DAO. You may also need conversions, because data inside of entity object is not matching SQL data, so you will have to write conversion functions. And this is all explained today, but with different example. This doesn't have conversions. So whatever is an object which is integer and string, just go directly. No need to convert. Next. After this, we have to create a database object. Okay. And this function, you see item database. Database is defined as abstract class. Why it has to be abstract class? Because this is interface. But you can see this is interface, and something needs to implement methods related to it. Right? So we cannot create objects from calling constructor. So it has to be abstract. Code is missing. So this is the reason. Next. This looks kind of mysterious, and it requires extra explanation what it is doing. All right? So what do we have here? We have class, and you don't have a constructor. But you need database object to do operations on it. Because once you have database object, you have access to DAO, and you can call methods of DAO. So this is how it works. Okay. So let me explain again. So you have, next, you need database object to do operations. You do abstract DAO. It's public, so you can call methods of it. Right? But you cannot create this object yourself. Why? Because you don't have an implementation of this interface. Okay. Something needs to generate this code. So this is why you cannot call constructor of it directly. But we need this object. How it is done? We create this object using database builder here. I will explain this part. So just for now, let's skip this part. So how this object is created? We call database builder. In database builder, it is static function. You see, static function of room class. So you can call it room dot because it is static. What is context? Context, it's a description of a program. And it is base class of many classes. For example, application class, activity class, what else? Service class. Okay. So why do we need provide context? The reason, please stop chatting. Stop chatting. Okay. So why do we need provide context to the database builder? The reason is that it needs to access hard drive in order to create or read files. So in order to access those files, it needs to know where they are. It needs to know where is the folder of the app. Okay? Because database for SQLite is just a bunch of files, it needs to know where to write them. So item database, it's a name of those files. prefix of the name of those files. It will be item database something, item database something. It will be 3 files. Okay? But it needs to know where to write them, so it needs to know context, information about the app. Essentially folder where it's okay to write stuff. What is this one? It is itself, right? What we have here is a reference to item database column class. What is column class means? Okay. Modern languages like Kotlin, Java, C# provide feature called reflection. So every object has description of what is there. And how it is implemented? It is implemented as data field inside of that object, linked to that object, that describes it. So what we pass here, it is description of the object that we have, item database. So database builder will know everything about this object, and this is linked to DAO. So it can collect information to generate code. Okay. So this is the behavior under the hood. Class, it's a data field inside of every object or every class that describes it. So you pass description of this class. And since this is part of it, it can read description of that and generate code. Why it is .java? Because it is implemented in Java. So it is Kotlin interface to Java code. Okay. So this is initializing database. Right? If it doesn't exist, it will create one. If it's there, it will find it at this location. But we need only one of these objects. We don't need to make 2. For obvious reasons, yeah. Because if we have 2, they will try to write and read the same location and it will crash. So we need to have 1. So somehow we need the mechanics that will guarantee that function that we call getDatabase will not create new objects. It will create the same one. Okay? Or not the same one. It will give existing one, or if it's not there, it will kind of create one. Right? So how this mechanics is working? If you call this one, it will create objects from the hard drive. Okay? So if database doesn't exist, it will create one. Otherwise, it will create object related to given database. So if it is called twice, you will get 2 objects, which is not a good idea because these objects will try to read and write the same files, so it will crash. So we need to avoid this kind of behavior. When it may happen that you get 2 objects. Yeah, when you call it second time, obviously, right? Or you can get situations that this function is called from 2 different threads of the program, which is kind of second time, but close in time, but 2 threads. So now we have a situation. How this function behaves? Please notice that this variable is in companion object, so it is static. Right? So it is shared between all objects, this one. Volatile, it means do not create extra copy in memory. So it is one location. Okay. Next, it is database either null or actual database. By default, it's null. So what do we have here? return this object, right? If it's not null, right? So this is how this behaves. This is always separator. Return this if it is not null. If it is null, execute this code and return result of the execution of this code. Okay? So if this item is initialized, it will give existing database object because it is stored here. It will not create a new one. So it will be this one. But if it is not initialized, it means it's null. Always operator will execute this part. Okay. And in this part, you see assignment of this database created also initialized, also is an object created, also defines it inside of Lambda function. And it is a reference to the object in front of also. So this is a database just created by database builder, database object just created by database builder, assign it to this instance. Okay. So mechanics, get database. It will give existing database object if it is not null. Otherwise, it will execute this code that assigns this part and returns this part. Okay? Because you have return statement. Where is the return? This part, right? Because either use this or this. Right? If it is not, if it is null, execute this one, but it's part of the return new one. And this part will also assign instance. So next time it will exist. So I explained this part, that creation, but not in detail. So this is supposed to create database object based on the location and description of this inside of this abstract class. What is this part? It's another piece of theory. Please pay attention. This one, fall back to destructive migration. So this part is also important. What does it do? Imagine that you release a program, and it is using some local database to store some data. Okay. After this, you release a second version, improved version of it. And user downloads it, and definitely user doesn't want to lose data when it's updated, right? Somehow you need to preserve the data in between. But what if newer version of your program is using slightly different tables? So somehow you need to convert data from the previous database into a new one. So it's a task, right? So it has to be done somewhere here in this area. So when you build the database, you do conversion to new one. In this case, it's not doing conversion. It is just deleting previous one. Okay. What is the logic here? It will compare version number. This version number is stored in the files of database. And if version number is different from the version number stored in the files of database, it will delete it. This is called fall back to destructive migration. Destructive means kill existing data. This is what we shouldn't do if we release a program, right? So in real life scenario, you need another method that will receive previous version number, current version number, do conversion of the data. So in real life scenario, there are extra steps, but it is definitely program specific. You need to convert data from previous version into new version. So in real life scenario, you will have another method call that is doing conversion, and you will have to write that code. In this case, it will just wipe off existing database, and it will start new one if version numbers do not match. Version number is stored in database files. So this is the meaning of this. Build will just create the object. So you provide the information, after this you build the object. It's not all the story. I didn't tell what is this. This is also makes sense. So what is this part? We already discussed that we don't want two database objects in the program. Why? Because they access the same data, they can corrupt the data if they write at the same time. So we don't want it. In this scenario, maybe you don't call it okay. When you access the data, remember you access it using IO, what's called? Dispatcher's IO. It is several tasks running in threads allocated to it. So potentially when we ask for data, it could be asked by two different threads because your program is calling for different data, essentially. So this code could be called by two or more threads close in time. So somehow, when database is being created, another thread should not try to create it. So this part is preventing it. So if one execution thread of the program is creating the database, another thread should not try to do it at the same time, obviously trying to create the files by two different parts of the program. The same files will cause issue, right? If it happens at the same time. How it works? Synchronized means do not execute this code in parallel by two different threads. So synchronized block means do not execute this code in parallel by two different threads. What is this? This is object, right? Which object? Not this one. It doesn't exist yet. It is companion object. Because this function is defined in companion object, and this is referring to companion object. Why would we need reference to companion objects in synchronized block? The reason is that you need to store information that somewhere that tells this piece of code is busy, do not enter. So you need a flag, like on bathroom of airport, right? Occupied, not occupied, right? So when one execution thread enters execution of this block, it flips flag. And in Java, every object has such flag. It's called lock. Okay. And every object has a lock for threads. So you can use this flag from any object. And it is used in synchronization of threads. So when one execution thread enters this part, it flips flag, occupied like on airport bathroom. So another thread cannot execute this. And this is how Kotlin works. This part is actually for entire line. So bottom line, this part, this object is storing the flag for synchronization of threads. So no two threads can try to do it. So this is okay. What do we have? We have a mechanics that guarantees that we have only one object of this kind per entire program, right? And this approach or design pattern is called singleton. Singleton design pattern. Singleton design pattern is implemented by having either private construct, like having private constructor, or not using constructor, using another method to create an object that guarantees that you have only one object. Because when you call this method second time, it will give you existing object. This is what happens here. It gives you existing object stored here, this one, if it exists. Otherwise, it will execute this code and initialize it, so next time it will give you that one. So this code is called singleton design pattern. It is one of the common ones. It is used to create global objects, essentially. Okay. Questions? Have time. Okay. So we started at 11. Now it is 12:30. So let's have a break, and we will continue. So we stop. I believe I explained in this file. Yeah or no? Okay. Before we go to break, let's look here. A version is already explained, right? A version number is stored in the files. And when you call this one, it will compare it, and it will kill your database if version don't match, and create new one. Otherwise, you will have to call another function to convert data, and don't call this one. What is this one? It's array of entities. Because database can contain more than one entity or more than one table, obviously. So this is why it's array. So you need to do comma separation if you have more than one table, right? Comma separated. And this is exactly why it is class. The same logic is here. Class is an object describing content of the class. And it is static, so it is one for all, and describing kind of what kind of data and kind of methods it exists. So this helps to generate code for this class. So you are listing what kind of objects you want to database in the database, and also you can have more than one DAO. So if you have more than one DAO related to the database, you create more than one DAO objects here. Okay. So this does not have to be one line. It can be as many as you like, DAO. Okay. And this doesn't have to be one. You comma separate if you have several entities. What is this one? It will create JSON file that describes the database if it is necessary for some reason. It is not necessary to me, so I say false. Okay. So this is to create JSON file for it. Okay. Next, last thing before we continue to break. Okay. So this database will be stored on the device as several files. But name of those files will start with this part, item database. So let's try to find it. View, tool window, okay, app inspections, build coverage. Device Explorer. It's called Device Explorer. So tool Windows Device Explorer. Click on that one. And this will show you file system on this virtual device. Okay. You see folder. This is slash. This is root of your Linux. So Android is a Linux. And you see it's not typical Linux. So they changed the code, obviously, a lot, right? There is a folder data. Open that. There is another folder data. Open that. And you have a folders per package. Okay, so let's find the one with what we have, StackData, and you see database, and here's the files. Okay, so this is where it stores the data. So it's their files. So before the break, I finished explanation of this file that is creating database object, right? So in order to get it, we call database, we call get database function, which is static of item database class, right? Now, how it is used? Now, it is definitely data is picked in view model, right? So let's see a view model for this for just a moment to remind ourselves what is going on. So where it is item repository, UI, right? Because if one view model belongs to UI layer. So UI comes stack. Here it is, stack view model. So view model needs repository in order to pick the data. Please notice that it is picking data by calling a repository get stack items, right? And these get stack items give me flow of list of stack item, and not list of strings or list of that stuff what we have, right? Please stop chatting because, first of all, it is what I'm explaining, it is not straightforward. Hello? Stop chatting. Okay. This is not straightforward. I promise you we will spend really a lot of time trying to learn it on your own. Okay? Stop chatting. Okay? Stop chatting. Okay. So, in the repository, we'll get list of stack items. So there is a data conversion somewhere. Where it happens? In the repository. So, repository. So I use repository, and I declared interface here. So I have get stack item or flow of list stack items. Okay. It is not the same as DAO. DAO gives me flow of list of strings. So I need to do flow conversion from a list of strings into a list of stack items. Okay? So we're about to see flow transformation, right? So this is our repository. I need this. I also need push string and pop returning the string. So this, if I have implementations of these three things, I'm done, right? So I need to implement these three pieces using DAO. Okay? So this is a local item repository. It's an implementation of item repository. Here it is. It needs DAO as a parameter, right? And DAO will contain already those functions. So first, I'm implementing get stack items that should return list of stack items objects. So I call DAO get items flow, which will be flow of strings. So I need to convert flow of strings into flow of stack items. I'm using map for flow transformation that we saw at the previous lesson, like theoretical lecture. We can do map for flow transformation. This is the item that is in the flow. So it is list, it is flow of lists. So every item in the flow is a list. So this is item in the flow. Map is picking this and call lambda function that is returning result, right? So this lambda function is creating another list. Okay. So what do I do here? I'm creating list from existing list. Right? This is pre-allocation. So list builder can allocate memory and use it efficiently. So what do I have here? In order to create a new list, I use loop. And it is in the context of list builder. So this add function is defined in the context of list builder, and this add will add item to this list. Okay. I use add in the for loop. In the for loop, I use index and value in list with index. Right. So this is how to create for each loop with index. Okay. Index starts from 0, and this is value. And list with index, it will be a list of pairs. Right. In that, I create stack item by calling constructor. Size with index, size minus index, it will be count, right? Size minus index, and this is value. Why do I need size minus index? The reason is that my count is actually size minus index, because index going this way, but count goes bottom up. Okay? So it is the reason why I have it. Count is size minus index. Okay. Index of this is index of this is 0, size is 5. Size minus index, 5. Okay. So because it is counted in reverse direction. So this was a transformation of the list. I did it with the loop to recount index from 1. Why do I need to recount? Because ID does not make sense here. ID is auto increment or in the table of database. It's not continuous. It really depends on what is current counter. So I really have to recreate index. And index is recreated inside of flow transformation. So this was example of a flow transformation. Okay. This one. What is flow on? At the previous lesson, we learned that flow can be optimized by specifying dispatcher. So you tell where to update, where to run the update on which dispatcher. In this case, it is dispatchers I/O. It is background task, optimized for input/output. And it's also this flow on is applied up the stream. So everything up the stream will be executed in dispatchers I/O. Right? So list is built in background thread. Background threads allocated for dispatchers I/O. Dispatcher. Okay. So this is flow transformation from flow of strings, from flow, not of strings, from flow of list of strings to flow of list of stack items. This is easy, right? It is push, you have string, and I'm changing context. Why do I change context here? Because we need to specify it somehow, right? And inside of view model, I didn't specify it. So if we go to view model, you see I call it view model scope launch. Okay. I could specify context here, dispatchers I/O in parentheses. But I didn't do it. Dispatchers I/O. So what is better? To specify context here, dispatchers I/O, or inside of repository. It is better inside of repository. Google recommends it. Because if you specify it here, but not in the repository, repository is the reusable part. So when repository is called in another project, user may forget to write, no, programmer may forget to write this part in new project. So Google recommends specifying dispatchers inside of repository. Although you can specify here, so you don't have to do it in repository. So it is in one place. Okay. Either in view model or repository. Oh, you can do both. It will not hurt if you do both. But it will not add anything extra if you do both. All right. So if it is done in the repository, you don't have to do it here. But potentially you can do it here instead of repository. So I remove dispatchers IO from here. And this is going back to repository implementation, this part. And I'm calling suspend function. You can call suspend function inside of another suspend function, just fine. But you cannot call it outside of suspend function. This is why my view model creates context. Which context? Coroutine context. Right? So what I have here is coroutine context to call suspend function. So if you try to call repository pop outside of it, it will be compilation error. Okay. Push, similarly, right? I create view model scope, launch, push. Okay. Now, so this is how it is linked to view model. I already explained this part before, but I quickly repeat what is going on. This function is returning list of stack items. See, list of stack items. But state flow contains UI state object, totally different type. So I have another map, which is flow transformation. And this is Lambda function with default parameter id, right, that creates object of UI state. And return value of this Lambda function, last element created, is used by the map to change content of the flow. So in the flow, it was list of stack items, and list of stack items is given to the constructor of stack UI state. See? Stack of UI state. So we create new object, and this new object will be in the flow. So I did another flow transformation. So this is another flow transformation. So up to here, it's a flow. But in this case, flow of UI states. So now it was flow of, it started as flow of list of strings. It turned it into flow of list of stack items. And now it is the flow of UI states. What is this part? This method of a flow converts flow into state flow. So essentially, it is attaching a container to store the state. Because flow is not storing data, it doesn't have capacity to store. It is just the chained transformations. So this is why it doesn't do transformations when you start collecting it. So flow is lazy. It does not do task unless something is watching it or collecting, pulling the data, give me the data. So state in this part is converting flow into state flow by attaching the box on the end, and it is pulling the data into the box for 5 seconds. Okay? Unless something starts watching the data. If GUI is watching the data, it will continue doing it. But if GUI is not collecting the data, after 5 seconds, it will stop pulling it. And obviously, it can pull it only when it is inserted on the opposite side. Right? So pulling will act only if data tables is updated. So state flow is hot, flow is cold. Hot, it means it's active. Flow is not. Flow, it is just chain of transformations that don't do anything unless something is pulling it, pulling the data. Okay. So pulling is also done in the background. Well, not in the background. It is done independently from GUI. So we created ViewModel scope. Why does ViewModel scope? Because as a task data is not necessary unless ViewModel exists, right? Because ViewModel is attached to the screen, and if ViewModel doesn't exist, you don't need the data transformation, right? So the data transformation task will be killed if ViewModel is destroyed for some reason, like you quit the app. So this is a task, this is the scope of the task that executes the pulling the data. All right? And this is just specification for how long it's to pull the data before you stop it, right? And you stop it, no, how long to pull the data after nobody is watching. So it is lazy worker, but not that lazy as flow. Because flow doesn't do anything unless somebody is kind of kicking it, like pushing the data, right? State flow is kind of lazy. It will work for 5 seconds unless somebody starts watching, okay? And if somebody is watching, it will continue working. If that somebody is not watching, for 5 seconds, it will stop, okay? So it is, this worker is kind of lazy, but not as lazy as flow. It will still work for 5 seconds if nobody is watching. After this, it will stop. Okay. And when we do transformation from flow to state flow, we need to specify initial value. Why? Because we're effectively attaching box to the flow to collect the data. So it is the initial value inside of the box. State doesn't have a place to a box. You attach it to the box, and we put the data there. So the data is required. So we can display it on the screen, and nothing is crashing. So this part is initialization of the data inside of the box. By default, you see a call default constructor. And in the default constructor, it is just empty list. So by default, the box is empty, but since data is coming quickly, we don't see this empty box. It's just whatever comes right away. So how do we get ViewModel? I previously explained this connection chain. This version of the program is not using HEALT, so it is manual dependency injection. So in order to collect the data, in order to connect all these objects, we created special object, and this object is linked to application class, StackData application. So application class is used in dependency injection. HEALT is using it, and manual dependency injection also used. So it's a place to store globals, essentially. So I created container object to store links of these objects that I want to connect. Okay. So this is container. When the container is initialized, it is initialized on create. So after constructor of applications code, it's called on create. So I call constructor of the container. And I pass context. Remember that database needs context. Description of the app. So this is where it's coming from. Context received by the database is application class. Literally. It's application class. technically it is parent class of application class, because application class is inheriting from context. So this is where database get context. It is a parent class of application class. Okay, so this is data container. So let's watch it. Data container, where it is? Data container, here it is. So what do I call? Item database. Remember that get database context is creating the database. Get database from item database. And item DAO, it's an object inside of database that contains operations. It's implementation of our interface, right? Okay. And this object is given as a parameter to constructor of repository. So this is how repository is created. Okay. Next, this is repository. What is lazy? Lazy delegates getter from this variable to this block. So when we call getter of this item repository, it will execute this code and it will give it. So essentially, it will initialize this variable only on as needed basis, one time. So it delegates getter that is initializing it only when you call it first time. So this is meaning of lazy. Do not execute this code until you check the data of this variable. But internally, it is delegation of getter. So container contains repository. So how this repository goes from container to view model? It is, again, in manual dependency injection, it is done inside of model view model provider. View model provider contains factory object. Factory, it's an object creating other objects. In this case, creating view models. So this factory I initialize with calling function called view model factory. It will create factory objects for view models. So initializer inside of view model factory tells me how to create that view model, and tells system how to create that view model, and they provide information called the constructor of stack view model. And what happens here? I call get application. Remember that application contains container, and container contains item repository. So this way, stack view model receives repository as a parameter from this magic. Okay. This function is defined here. It is calling lambda library magic, creation extras. So this is a creation extras. Creation extras view model provider, this Android view model factory application key, and convert it to StackData application. This will be application. And we pick data from that application. So this is how view model is injected with repository. So Google course keeps doing it in all examples, except the Google course version that is using Firebase. Since we're going to use Firebase, that example is not using it. It's using Hilt, but it's not explained. It is explained in the example of Firebase. But I started explaining this earlier because in order to understand how it works, it's better just to see it multiple times. So, Hilt version. Switching from main to remote using Hilt checkout. It says blah, 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 force checkout. And since I switched branch, I need to synchronize project because now it is using different libraries. So synchronization is elephant. So if your program, or my example, behaves such way that a lot of stuff in red, you click elephant, and elephant will it is icon for Gradle. Elephant is icon for Gradle. A resynchronized project. So when we use Hilt, we don't need to add containers to application class, but we still need to use application class. This annotation will generate code automatically to create containers. We still need to mention application class in manifest as before. Here it is. This is application class. Otherwise, program will crash when it starts. Next. So this is happening in stack application class. I need to write it. Next, in main activity, I need to write Android entry point on top. Required. Otherwise, again, it will crash at the time of starting program. After this, I need to provide information how to put things together. Right? So first, I need to, so this is view model. When view model is marked with Hilt view model, it makes it injectable into view model function. So view model function can use it. You don't need to provide factory to view model function. Previously we had to, but now not this one. So if I'm switching quickly back to main branch to show you that in the main branch, when we use view model function, stack screen, we have to call it with factory as a parameter. So in manual dependency injection, view model function is called with factory as a parameter. When we use Hilt, we do not provide factory because Hilt will provide the factory automatically. So with Hilt, there is no factory in view model function call. I'm going back to using Hilt. To the same location, StackData UI, stack screen. You see there is no factory here because Hilt is providing factory automatically. But you still need to tell information how to create this object. Okay. So a view model needs this part, which is item repository. Item repository is interface, so you need to link interface and implementation. This is what Hilt needs, link in implementation. So this is interface. Okay, so with data repository, item repository is interface. Implementation is this. So we need to connect these two. We can connect it with data module. Okay. In this program, I decided to use not binds, but provides. Because this way I can have one module instead of two. So let's see what is going on. This part tells the system how to provide repository to view model. This one. Provides and only one of them. After this, just provides a copy of the existing one. So a singleton in this place means create only one object, keep copy, and when it is asked again, give the copy. Okay. So this function provides repository to dependency injection system. But in order to call the function, I need to have DAO, right? So before calling the DAO, this DAO, it needs to call provides function that returns DAO. This one. and it is picking database.dow. But before calling that, it needs to call function that provides database. This one. And it is this one, provides database. This function needs application context, and application context is available to Hilt automatically. So we don't need to create provide application. And how database is created? Item database, get database, application context, right? As before. So we need to create methods that describe how to create those objects. Okay. Okay. Please notice that this one is called inside of provides function, so it doesn't need to have inject in it, and it doesn't, you see? Because it is called as a constructor inside of provides function. So provides is doing providing, not constructor. Okay. If constructor does provide object, I will have to say constructor inject. Questions? Definitely, connection between objects can become complicated because we can have several modules, several provides, several binds. So internally, Hilt is quite complicated because it needs to build dependency graph and figure out what is the proper sequence of calling those functions, such way that all objects are created. So Hilt is designed for larger size applications where manual dependency injection becomes too much. Okay? So, but we still learn it because the purpose of this course is not to learn how to do simple things, right? It is to provide background so you know background how to write bigger apps, right? When you do, for example, capstone project, it's a large app. So this is my rationale. So even if we use simple apps, we still learn later in the course, like here, about midterm, complicated things necessary in large apps. Okay. Questions? How much time we have? We have about 20 minutes, and I have about 10 minutes of additional information. I think I don't want to spend time explaining this GUI. The reason is that this GUI it is just, I would say, a little clumsy, but there is nothing special in it. It has the list, it has text input, buttons, and we already had it in other programs. But we have an example with more interesting database, and I want to spend time explaining that part. Okay. So I assume that this project is done, and I will probably will not return to StackData, because GUI is just a little tedious, but it is straightforward. You see, this is a list of items, this is view model, mentioned there, this is item of the list, whatever. It doesn't have any specifics that needs to be explained, besides just tracing the code. So for this reason, I probably will not return to this example again unless there is something else added to it. Okay? So for now, let's stop it and let's open another project. Tap to the continue trust. Okay. Another project that was already discussed before, and it is product list.